So my first question is, what do you mean by time complexity? How to measure the time our program is taking to execute? How to measure that, by the way? Seconds, hours, minutes, what is the measure? Anyone knows that?
Big O.
Big O is a notation, I guess.
Okay.
So it's measured in terms of unit operations. Can anyone tell that how much our CPU, normal CPUs of our computers can execute in 1 second? How much operations? So the allowed limit is 10 to the power 8. This is in majority of the OAs, whatever you are gonna give, the online assessments, the time limit for any program that you get is 1 second only. So no more than 10 to the power 8 operations I can do, okay, in 1 second to solve my entire problem. There will be tons of test cases. There will be tons of test cases, and each and every test case result should be produced in 10 to the in 1 second only. That means just within doing 10 to the power 8 operations, okay, I should be able to grab all my results. If it is taking more than 1 second, if your program is taking more than 1 second, you get a verdict of time limit exceeded. That means you have to optimize your solution now. Okay. Either you may be having some glitch in your code, or what is happening is that your algorithm is faulty here. It needs to be optimized. Correct. So let's see some basics that how to calculate this time complexity. Whatever we do, right? We take input, you print the output, you do basic mathematical calculation, plus minus, division, multiplication, whatever it is, modulus operation, whatever are they. All these things are being done, is including the conditions, right? A is greater than B, B is greater than C, A is equal to that of Z. All these things, the basic mathematical or logical operations can be done by my CPU it's rather some constant C unit operation. So this constant C is such a low thing that it's not actually distinguished with just one unit operation. So all these operation, how do we denote it? It's big O of 1. Big O determines that let it be whatever the scenario, maybe whatever, however maybe the large data sets are, right? At the worst case, even in the worst case, these things will be done by my CPU in no more than one unit operation. Let it be any large data sets, let it be any kind of input. All these mathematical, logical input, output, and any kind of operation, the basic operation we are doing can be done by my CPU in no more than big O of 1 time. Correct. Now my point is, all this operation that you have done, how many times you are doing it? How many times you are doing it? That depends upon the input n that you are taking, by the way. Input size n that you are taking. Okay. Larger the value of n, more optimized should be my solution. Correct. Let's see how to judge it, by the way. Let's see. Let's take a simple example to start off with. And let's have a loop here for, let's say, I that starts from 1, I that goes till n, let's say, and I plus plus, I plus plus. I just say system dot out dot print whatever is the value of I. Let's run the loop for I equal to 5. Tell me, can you try telling me that what will be the flow of the program overall? How it's gonna happen? How many times? Let's see that my initialization will be taking place. This is the first initialization, right? Inside your for loop, the first thing stands for initialization. I declared a variable I, and that has been assigned some initial value 1. So the initialization took place once, I guess. Not more than once your initialization of the variable will be happening, right? So one operation for this, one operation, assume one CPU operation for this. So I did one operation here, plus how many times this will be happening? The comparison will be done how many times? Anyone?
5 times. N times.
Okay, so whenever my Whenever my I is equal to 1, it will be compared with 5. Whenever my I equal to 2, it will be compared with 5. Okay. And then I will keep on increasing. I will be, when I turns to 5, it will be now lesser than equal to 5 for us. Is there any other value for which the comparison will be happening? Whenever I turn 6, now again a comparison will be happening. Am I correct? And when the
Yeah.
comparison will be failing,
False.
the condition will be false, then my loop will terminate. That's how your loop works. All of
Right.
you agree with me here?
Yes.
So overall, how many times we did it? We did it n plus 1 times. Am I correct?
Yes.
For the initialization, this is for, I guess, the comparison, right? Comparison. What about this? How many times it's gonna happen? How many times your,
N plus 1.
okay, from 1. We started off with 1, then after from 1, there is 1 increase. From 2,
Hmm.
there is an increase to 3. From 3, there is an increase to 4. At the end, 5 is increasing to 6. So let's write it somewhere. 1 increase to 2, 2 increase to 3, 3 increase to 4, and at the end, 5 increase to 6. How many increment happened? N increments. Am I correct? No more than that.
Yeah, till N plus 1. Yeah, N increments. Yes.
So there are N increments in total. Correct? Okay. And at the end, the main thing what we are doing, the print operation. How many times that has happened? N times? N
Yes.
print operation in total. So overall, how many operations we did here? See, all of them, the single comparison, the single initialization, the single increment, the single print, all of them are what? Equal to that. All of them take exactly or near to about 1 CPU operation, not more than that. That's exactly some constant C unit operation that can be thought of. It's so small that computer takes no more than 1 CPU operation to solve these problems. No, the problem is how many times you have done that. So this is the overall number of time that we have done it. Add it. These are the overall operation we are doing, right?
17.
It is 3n
17.
plus 2, right? It's 3n plus 2. Now this is
Yeah.
the overall number of operations I got, correct? Now if you try enclosing that, how to represent that in terms of Pig-O notation? Pig-O notation tells us that enclose the overall number of operation, okay, inside the program, and these are constant values, 2 and n. 2 and 3 are constant values. The only thing that can increase or decrease the number of operation for you is the change in n, not these values. These are fixed. Only the change in n can affect your increase or decrease in overall operation, correct? So don't keep this constant inside your Pig-O notation. Whatever is the variable that's affecting your program should be there. So overall, what's my complexity? Pig-O of n, of the order of n, my complexity stands for. And we have seen that this is roughly equal to how many times my loop is running. Am I correct? How many times roughly my loop has run? My complexity depends upon that. Am I correct? Am I wrong? So
In this case, yes.
overall, how many increments happened? How many comparison happened? How many prints happened? Individual tracking is not that required because they are gonna affect for us some constants. Just my point of concern for me is that how many times the loop has run here. Correct? That's what I need to focus. All of you are clear with this topic here. Please tell me.
Can you please repeat once again?
Okay, which part? Can you tell me?
That init comparison like 1 plus n plus 1 and then.
So init is what? How many times the initialization happened? I will be
Okay.
declared once and just will be assigning its initial value. Only once that's going to happen, right? The rest of the value of I will be compared. So how many comparison happened here? Overall n plus 1 comparison. Whenever your value of I is changing, that amount of time for valid, for running the loop, whether the condition is still valid.
Yeah, that I understood. For 5 two times and 1 false.
Yeah. And then we are saying how many increments there are. Overall n increments here, right? 1 increase to 2, 2 increase to 3, 3 increase to 4, and at the end 5 increase to 6. Overall n times increment has happened here. So what is my n times, and at the end n times print operation happened. The overall number of operations for my this loop is 3n plus 2. If you add up everything.
So if it is only not equal, less than equal to n, if it is only less than n,
then accordingly your operation will be changing. Okay, for one value less, this particular comparison won't be happening. One time
yes.
will be going away. These are the things. These are small
So,
things.
so
that you
prince will be n minus 1, right? Prince will
Which-
be n minus 1, right?
Which one?
Prince will be n minus 1, right? We
Yeah,
have
then
given.
print will be n minus 1. Yes.
Okay.
Okay. So I tried going ahead and I said that overall number of operations for me is 3n plus 2. And inside the big O notation, you don't keep any constants. You keep the variable which is affecting your program. Increase or decrease of the value of n can increase the number of times my loop is running, can decrease the number of times my loop is running. So only n can affect. 3 and 2 are constants. They are not going to affect the program. Okay, they are not responsible for increasing or decreasing unless and until n is affected. This is the main variable for us. So I neglect these terms and I keep the only way changing variable inside my big O notation. So final complexity turns out to be big O of n. Effectively, this means I am really concerned about how many times my loop is running. Overall, how many times my loop has run. Correct? It's not about always considering how many individual operation is happening, because they are just contributing for me to some constants, the 3 and 2, which hardly affects your program. The main point of concern is how the variable is behaving inside my number of operations. Correct? Till this point, is it clear to all of you? First, tell me that.
Yes.
Can we move on?
Yes.
Can
Yeah.
we move on? All of you, I want the answer from you people.
Just one question I had, like for
yes.
if there are couple of for loops, then it will be
Coming to that point. Coming to that
okay.
point. Just wait. We will take every example in an organized manner. Just don't worry about that. Okay.
Sure. Thanks. Thanks.
Can we move on? Can we move on?
Yes, please.
All of you. I am not getting responses from many people. I don't know.
From next session, we can have the video on.
Okay. Sorry for that today.
Yeah.
There is some kind of internet issue that's going on from a few minutes. That's why I've kept it off.
No, not for you, Mustafizur. It's for everybody. Like
maybe. Okay. So yeah, let's take another example. And here what we can do is that let's take a example like this. My I is moving to I starts from 1 I less than equal to n. I plus plus. And inside that, let there be another loop. For I that again starts from 1 I less than equal to n again. Let's say, sorry, it's not I. Let it be another variable j. And j plus plus. Then you have to just try printing system dot out dot println the value of j. Try coming up that how many times your loop is running. Try thinking for 2-3 minutes, then give me the answer.
N square times.
Okay, how is it n square? Can anyone tell me? How is it n square? How? So effectively what we figured out that in my previous program, how many times my loop is running, that's the matter. No matter that how individually each and everything is behaving, that's not a matter for us. So I require to find out that what should be the complexity for this program? How if even if it is n square, how it is so? Anyone? So okay, let's try to figure out. For I equal to 1, right? How many times my j is running? Can anyone tell me?
N times.
N times.
Yeah, for I equal to 1, what is happening? Jth loop is running from 1 till n, 1, 2 till n. And for each and every value of j, there will be a print, right? There will be a print. Wherever j is pointing, that value will be printed. So 1 got printed, 2 got printed, 3 got printed. At the end, it printed till n times. Then inner loop will terminate. You will go back. I will be increasing, right? I will be increasing to 2. Again, j will be reinitialized. Again, jth loop will be reinitialized from 1. It will go till a series of increments from 1 to n. And again, the values of 1, 2, 3 till n will be printed. Am I correct? That's how your loop behaves. That's the behavior of your loops, nested loops.
Yes.
Yes or no?
Yes.
Yes, sir.
Okay. Then again, I is gonna increase. Then I is gonna increase again. Again, J reinitializes. Again, whenever your inner loop will be over, it's gonna go back to the for loop. Then I's value will be increasing. 2, 3, J is gonna. Then again, you start off with the new Jth loop. That J again starts from 1, it goes to 2 till N, and we print 1, 2, 3 till N, right? Everything gets printed. This is gonna continue till I equal to N, right? Whenever my I reaches N, that's the last value of I for which there will be a Jth loop that's gonna run from 1 to N. Am I correct? Am I correct? Beyond I equal to N, there is no more J loop that's gonna run for you. Am I correct? Am I wrong?
Yeah, correct.
Yes.
Okay, so again 1 to N will be printing for the last time whenever I is pointing to N. So overall, how many times my loop has run? Overall, both the loops has run how many times? Whenever my I equal to 1, there is an inner loop that has run for N times. Whenever my I equal to 2, the inner loop has run N times again. Whenever I is equal to 3, the inner loop has run N times again. Whenever my I turned 4, the inner loop has run N times again, till the time my I reached N. And at this point, there was the last time the inner loop ran for N times. So tell me how many times overall we have run our both loops. So for N values of my N values of I, the inner loop ran exactly N times. So overall number of times my loop is running is N square. Am I correct? Am I correct on this part? For each
Yes,
and
sir.
every value of I that ranges from 1 to N, your inner loop is running N times. Am I correct? So overall, how many times your inner loop has run? Overall, how many times the loop has run? It's N squared times. That is the reason we say whenever we have two loops, the complexity is N squared, but that's not exactly the case every time. It's just a simple example. Correct? Works for you? Can we move on? Okay. This is a simpler one. Let's take a little bit different one from here. That let's suppose you're having a loop like this. For I that starts from 1, for I lesser than equal to N, let's say again for I plus plus. Let's have another loop for J that starts from 1. J lesser than equal to I, J plus plus. Now tell me, and here you do anything, yeah, do any task. Let's just like print or do anything. Tell me for this time, how many times your loop is running exactly? Task means you can print anything, you can do anything. But my point of concern is how many times my loop is running now. Can you try this? Try this, all of you.
Mustafa, I'm really sorry. Can you please explain that again? That just went on my head. I'm really sorry.
Which one? Which one?
The like how it came to ends.
Okay, yeah, sure. So see, how we are just concerned about how many times the overall loop is running, right? So we know that for each and every value of I, my jth loop will run n times. Am I correct? For each and every value of I that ranges from 1 to n, correct?
Mm-hmm.
Your inner loop is running exactly n times. So overall, the inner loop ran how many times?
Right.
For all the n values of I, my inner loop ran n times. So overall number of times my loop is running is n squared.
Sure, I see.
That's why,
okay.
yeah, that's how your complexity turns out to be big O of n square.
Mm-hmm. Yes, got it. Yeah, thanks for that.
Okay, try
Now
for
what? You're trying for what?
this particular part.
Okay.
For I equals to n, J is running for n times. So I think it's n into n.
Let's see that. Let's see.
N plus N, I think. 0 of 2N.
Okay, for I equal to 1, how many times the jth loop is running? Let's try writing.
1.
Once.
For only j equal to 1, the inner loop will be running, right? Okay, next.
Yeah.
I times.
For I equal to 2, how many times the j will be running? 1 and 2. For j equal to 1, j equal to 2, for these two values, your
Mm.
loop is gonna run. For I equal to 3, j is gonna run from 1, 2, and 3. These three values, am I correct?
Mm.
At the end, I can say for, let's write for I equal to n minus 1. How many times the jth loop will be running? J equal to 1, j equal to 2, j equal to 3 till j equal to n minus 1.
Mm. So,
The last value, right? Okay, then we say for I equal to n, j runs from 1 till,
yeah.
okay. Now tell me overall how many times we have run our loop. Tell me that. Overall, how many times you have run the loop? For first value of I, the loop ran one time, right? For the second value of I, loop ran twice. Third value of I,
n
it ran
factorial.
thrice. It ran thrice. Then for the second last value, it ran n minus 1 times. For the last value, it ran n times. So overall, how many times we are adding it? So add them one by one. It's gonna be 1 plus 2 plus 3 plus till n minus 1 plus n. Am I correct?
Yes.
Yes.
Am I correct? This is the overall number of times your loop is running. So what is it
Hmm.
all about? Sum of first and natural numbers. N into n plus 1
N into n plus 1 by 2.
divided by 2. Enclose that in big O. This is my overall number of operations roughly that I am doing. 2 is a constant, neglect. 2 is a constant that is neglected. Okay, again, what we are left with, big O of n square plus n. Inside the big O notation, you keep the highest power term and neglect the lower power terms. Why that is so? Let's see that. Let's see that. But why is it so? Because if you even, what we are left with is big O of n square plus n. If you increase the value of n to 10n, let's say, which term is getting affected more inside my big O? Can you tell me? You increase the value of n by a factor of 10. Then which term inside your big O notation will be affected more? So it's gonna be big O of, I can say 100 n square plus 100. So overall, let me just count for the number of operations right now I'm having. It's gonna be 100 n square plus n plus 10n. As compared to this, there is more increase in the next term because its power is higher. Correct? As compared to, so this particular term affects little, okay? This particular term affects less as compared to that of the highest power term. So inside your big O notation, you don't keep lower power terms. You just say whatever is the highest power term, just keep that. Because it will affect your number of operation more as compared to any other term in the program. So your overall complexity is gonna be big O of n square again. Got my point? Got my point?
Yeah. Yeah.
Is it clear to everyone? Is it clear to everyone?
Yeah.
Actually, can you give some more examples
Yeah,
so
we
that
will take. We
we
will
try?
take. Don't worry. And don't worry, this is just the start. With every problem that we will solve, there will be complexity involved. Without that, we cannot move ahead. This is just the starting point. For every problem, there will be complexity involved from now onwards. Because if you are not aware with complexity, you cannot at all judge how to solve a problem inside an OA, right? Based upon the constraints that are given. Based upon the constraints that are given. Okay, fine. Let's take this example, by the way. Okay, let's take the previous days. Does anyone has the previous day code, whatever we solved for this particular problem, I guess? Which problem did, that was having two loops for us, but it ran linearly in our case in the previous day. What was that, by the way? Repetitions, I guess, right? This problem. I think I have solved it, and let me just try this. Try having the code from here. Just a moment. This was the overall loop, right? With which we were doing in that day. Am I correct?
Actually. Mm.
Is it visible now?
Yeah.
Yes.
Okay, so let's focus how many times this was the loop for us. How many times is it at all going on? How many times did it run yesterday? What we have judged, by the way, let's suppose it was AC. Sorry. It was, let's say, ATTC, GGG, and yeah, let us keep it till here only, or we can reduce the string further. we can reduce the string further. It's gonna be A, T, T, triple G. Let's suppose this is our string. So I started off my loop. I started off my loop from I equal to 0. That's what we were doing effectively, right? And my J was initialized here. My J was initialized here. What was the overall, how it went previously with the help of 2 pointers? That we were just compare. I don't think this was our code that day, but yeah, a little bit change here because I haven't submitted the Java part. Anyone has the Java counterpart with us? Okay, fine. This is also sufficient, I guess. We don't need anything. Or let me write it somewhere else. What should I do? Whatever it is. Okay, fine. So my J, what we were effectively trying to do is that we were segregating the different characters inside a single subarray. That which particular subarray is having all same characters, and in what is the longest length of the subarray which is having more which is having same characters. That is what we were trying to find out. So what we did effectively here was that we tried to visit. I initialized the ith pointer that considering this character towards its right, how many characters are continuously same, right? And I try finding out that with the help of the jth pointer. That's what we did. Am I correct? Okay, right now I see that that jth character, the jth character is not equal to that of my ith character. So for that I kept a count to initially 1 that we are inside my substring. Inside my substring I'm already having the ith character. So let the count be 1 and we are having a max value. What is the max length of my substring that we were having, correct? Max length of the substring that's having the greatest same number of elements. So yeah, since the ith character is not equal to the jth character, if I consider this substring as an answer, then this substring is overall not having what? All the characters same. So this cannot be considered as an answer. Whatever is currently into my substring that is being pointed by only the ith pointer, let that be my first possible choice of answer. So I said max value will be updated to 1. That's what we said. And then let's try figuring out what is the longest substring from the jth pointer. So I shifted my I to the pointer j. That's what we did. So A, T, T, triple G. Correct? So my I is here, my j is here, correct? I is here, j is here. So after I shifted my I to the jth pointer, I will reinitialize my j to I plus 1. I will reinitialize my j to I plus 1. And again your count will be reset to 1. That right now only the ith character is into your current substring that is having the same character, and your max value is 1 only for us. Max doesn't changes. Max is accountable for what is the overall maximum length substring for us that is having all same characters. So right now I am trying to figure out how many substrings, what is the longest length of the substring having all characters as t. So it's going to start up from the ith pointer. Let me initialize j to I plus 1. Since the jth character is equal to that of your ith character, increase your count to 2. That right now into my substring, there are 2 characters having the same, there are 2 characters, all are same. So, okay, now increase your j again to the next pointer. G is different than your ith pointer. G is different than your ith character. So, I know that prior to, right now I am at G, from I to j minus 1, whatever were the characters, they're all same. What is the length of that substring? 2. Increase your answer to, increase your max value to 2. That a 2 length substring can be a better choice for me as compared to the previous one, correct? Now again, what I'm gonna do, I'm gonna say A, T, T, triple G. Right now I'm gonna say, okay, G is a different character. Try finding what is the longest length substring with all G's. So I'm gonna say it starts from the jth character. Put your I to the jth pointer. Okay, put your I to the jth pointer, and then reinitialize j to I plus 1. Again, reset your count. Right now only the ith character with me, okay, is inside the substring. That's it. Now put your start of j from I plus 1. Then jth character is equal to that of the ith character. Increase the count. Again, take your j to next step. Jth character is equal to that of the ith character. Increase the count. And then j goes out of the bound of the array. So from here onwards, there are no character left to be judged. Finally, I say that count. What is the count of my current substring? That's 3. So that's more than my overall max length substring with all same characters right now. So increase it to 3. So finally, my answer will be 3. Whatever is stored inside your max, that will be my final answer. So this is how we maintain the 2-pointer approach, and still there are 2 loops. But my point is, even if we are having 2 loops, what is the number of operations that we have done. How many times effectively my loop has run? Can anyone tell?
N times.
Yeah, so how can you judge that n times? Because any of the character, right? Any of the character in the worst case, any of the character in the worst case can be visited by both ith pointer and the jth pointer. So at most, any character can be visited by the 2 pointers, not more than twice. Correct? Once I can visit it, once J can visit it, not more than that. So how many characters are there in characters? So I can say 2n is my overall number of operations here. And my 2 is a constant, I can neglect that. So overall complexity will be linear in nature. Linearly, even if there are 2 loops, my overall complexity is going to be a linear we go of n. Okay, you have to count that overall number of times. What is the number of operations we are doing? Rather than going onto the fact that how many times, if there are 1 loop or 2 loop. The loops doesn't matter, but how many times effectively, roughly they have run, that matters for us. Okay. Is it clear?
No, this one is not clear to me. I don't know why. I'm not able to understand this part.
Yeah, just come again around the like the inner loop is going at most twice. That I didn't get.
No, not inner loop is going. My point is, what you have observed here, any of the character from here are there, A, T, T, G, G, J can, any of the character can be visited by J once, can be visited by I once. Is I visiting all the characters? Is it happening? Is I visiting all the characters here? Is it happening?
No.
No, right? No. So A, T, T.
Why is not?
I visited this A, then I visited this T, then I visited this G. None other character is being visited by I, right? None other characters is being visited by I. Correct? Am I correct? Correct. For I equal to 0, how many times the J has run? J only visited, I guess, character 1. Am I correct? Sorry, character at the first index. Whenever my I was at 0th index, J has only pointed to the 0th index, the first index element. Nothing more, I guess. Am I correct?
Right.
Yeah. Moreover, then I shifted. Since both the characters were different, I shifted to 1. Let's try finding a substring from the first index, from the first index onwards. Because that's a different character. How many from that character, how many are same? I wish to find out that. So I will be pointing to 1. And from here, J will be going where? What particular index is being visited by J? It visited 2,
I plus 1.
it visited 3, right? Both the characters. First it went here, then it went here. 2 visits, am I correct? 2 visits. Then G was found to be different, so I shifted my I to the third index element. And here J pointed to index 4, index 5, and when J pointed to 6, my overall loop got over. Am I correct? Overall loop got over at this point. How many times in total we have run our loop? Calculate that. First time, for not all the values of I, my jth loop will be running. I will not be pointing to each and every character firstly, and even if it is points to corresponding to each I, corresponding to each value of I, J is not gonna run n times. That's not the thing.
Right.
So overall, how many times my loop has run here? Anyone? 1 plus 2 plus 3, right? So it's effectively again going till n operations. Am I correct? That's the more case. In the worst case, how your string is gonna look like? A, B, C.
How it is 1 or 2. Oh, okay, yeah.
A, T, C, G, let's say. Let's suppose in the worst case, your string is like this. All the characters are unique. Then what will happen? Can I say in this case, try figuring out. Can I say in this case, all the characters will be visited by INJ? Roughly all the characters will be visited by INJ. Tell me that.
For I, yes. For J.
For I, J is not visited, I think.
Okay, let's see. Firstly, my I will be visiting this A. Am I correct? My I
Yes.
will be visiting this A. I is at 0. Now Jth character is different, right? J will be only visiting this 1. Now my I will be shifted to this T. From here onwards, what is the longest length substring that comprises of only T? So I am gonna say I now shifts to 1 and J is visiting this 2. Am I correct?
Yes.
J will be visiting whenever ATCG is there. I will be here, my J will be pointing here. Again, J is a different character than the previous one. And then J is a Jth character is prevent than the previous one. So I can say again, next I have to start seeing what is the longest length substring that comprises of C, and that C starts from the Jth character, correct? Okay, so my I will be pointing to 2 and J will be pointing to, now when I points to the C, J points to G. J points to G. So J is pointing to the third character. Okay, fine. Now I say that again, this is a different one. So I has to be shifted to J, G, and J will be pointing out of the bound of the array. So now I points to the third character, and here corresponding to this, J points to somewhere called fourth index, which is not existent. So the loop will never run. The while loop will never run. So roughly I has visited all the characters, and for each and every value of I, not more than once my Jth loop has run. Am I correct? If my I is visiting
Right.
all the characters, the Jth loop will not be running more than once. Am I correct? Am I wrong? Roughly can I say all the n characters have been pointed once by I, once by J. So overall, how many times we did? We visited each and every character. How many times? 2n times. Once by I, once by J. That's it. So if I enclose that into big O, 2 is a constant, neglect. Final complexity will be big O of n. That's it.
Got it. Mm-hmm.
So that's why don't please judge that whether there are one loop or two loop. Just judge how many times your loop is running in an overall manner. That's what is complexity all about. Tell me, is this part clear so far?
Sure. Yeah, it is clear a bit to me. Like this example is clear. Like I
Please
think we have to
revise this
practice.
once you go, it's first time, so revise this once more. Because it may take some time to
Sure.
clear up.
Right.
Okay, fine. Let's move on and let's see another example that's quite a bit interesting one, I think, right? Let's say here that for I that starts from 1, I goes till less than equal to n, and let's say I multiplied equal to that with 2 and print the value of I. Print the value of I. Can you try this?
What is the condition last? Like in for the
I multiplied. I will be multiplied every time with a factor of 2. Can you try this, all of you? Please try this.
It's coming as 0 n by 2. 0 of n, I think it is coming.
Okay, fine. Let's see. So suppose that fine. Let's suppose your value of n is 10. Then how many times the loop is supposed to run?
5
Five
times.
times.
For
5
I
times.
equal to 1. For I equal to 1, it is going what? For I equal to 1, it is the condition is true, right? I is less than equal to 10. True? Okay, fine. So 1 will be printed. Next time from how the value of I will be changed?
2.
into 2.
So I will be turning 2, right? 1 into 2, that's 2. Okay, now tell
Right.
me, now 2 is again lesser than the value of n. So loop should run and 2 should be printed, right? Next,
Yeah.
again, I will be multiplied, it will be 4. Am I correct?
4.
So 4 will be printed. I will be multiplied, it will become 8. Then 8 will be printed, and whenever I become 16,
Yes.
it ends up. Fully it ends up, right? No more printing because it has gone more than n. So my point
Yeah.
is, what we are printing here, can anyone tell me? How many times effectively the loop has run?
1,
First
2,
it
3,
ran
4,
for 2 to
5.
the power 1. Then it ran for 2 to the power square. Then 2 cube. So based upon the value of n, it's gonna run for some power of 2 to the, or some power of 2x. Am I correct? And this power should be the last power of 2. That should be lesser than equal to n. Am I correct? This is how the sequence we are running for I.
Yes.
Because your I is again and again getting multiplied by 2. So with some largest power of x, this will be the last value of I with which my loop is gonna run and print the power of 2. And now see for one thing that overall, can I say x number of times my loop has run? Can I say that based upon the powers of 2 we printed? It
Yeah,
started off from 2 to the power first, then 2 squared, then 2 cube. At the end, some 2 to the power x depending upon the value of n, right?
Yes.
Say overall, the overall loop has run x times. So what is this value of x now? I can just say in the
Log of n.
yeah, I can just say 2 to the, in the worst case, 2 to the power x will be just equal to that of n, right? In the worst, this is the maximum value 2 to the power x can achieve. Correct? So what is the number of this x? You apply log 2 both sides. Log base 2 value 2, since the x is in power terms, it comes as a multiplication form. As per the properties of logarithm, x term comes as a multiplication term. So if I take log 2 both sides, then how my representation will be? X into log 2 base 2 equals to that of log base 2n, taking logarithm both sides. What about this value? What is this value equal to? Log base a value a for all valid values of a. This will always be equal to 1 as per the properties of log. Correct? So my x, it remains like x is equal to log 2n, log base 2n. So effectively, how many times my number of loop, my loop is running? X times, right? So what is the value of x? Log n. So what's the complexity for this? For this loop, it's big O of log n.
Mhm.
Okay.
This one. Yeah, it was not completely understood.
So effectively, what happened here is you're transiting now powers of 2. You are constantly multiplying your values with 2, I guess, right? And whenever
Right.
we achieve the largest power of 2 to be x, what happens here is that what can be the maximum value of 2 to the power x? It should be lesser than equal to n. Whenever this becomes 2 to the power x plus 1, my loop stops because it has gone more than n right now. 2 to the power x is the largest power of 2 that can be printed by my loop. So effectively I say started printing from the first power of 2, maximum till x power of 2 I can print. So overall x times my loop is running. I can say that, right? Overall from the first
Right.
power to the x power I can run. What is this x? What is this x?
That's
So that is,
No.
how can I find out that? I say that 2 to the power x equals to n. So I can just say apply logarithm of 2 both sides. Apply log 2 both sides. So what will happen is that whenever you apply that, your x in terms of power it will come as a form of multiplied factor. And what we will be left with? X into log 2 base 2. X into log 2 base 2. This term is equal to that of 1 as per the properties of log. So we will be left with x equals to log 2n. What is the value of n we got? It's log 2n. So I can say my overall loop has run log n times, where base will be 2. You can neglect the base as of now. So my point is, log 2n times my loop has run. So overall complexity is what? How many times my loop has run? Big O of log n. Okay. Big O of log n is the number of times my loop has run. So my complexity is big O of log n. So these are some of the calculation things for the complexity purpose that you must know here. Similarly, you can have another example like this. That n, first you started off with n, then n got divided by 2, then n got divided by 2 again, then n got divided by 2 again. And at the end, it reduced to 1. Then what is the complexity of this? Can anyone tell me? You are just doing what? You are running a loop here. While n is greater than equal to 1, let's say. And you are saying again and again you do what? N divided by equal to a factor of 2. Then what's the complexity of this?
Like then it will be square root. Like
Again see what is happening. Again, you can relate the pattern. N is first getting divided by 2 to the power 0. Its first term can be represented as n divided by 2 to the power 0. Then I reduced it to n divided by 2 to the power 1. Then I reduced it to n divided by 2 square. Am I correct? Then I reduced it to n divided by 2 cube. At the end, since there is a constant division by 2, right? Since there is a constant division by 2, at the end, I divided n. The last term can be thought of that after you divided n with some highest power of 2 to the power x, this value turns out to be 1. And here the loop stops. And after this, the loop stops. After constantly dividing n with powers of 2, after dividing it with highest power of 2x, that's possible, I turned it to 1. Now, how many times in total the division happened? How many times the loop has run? We can say roughly x times again. Roughly x times again. Now, what is this time complex? So how many times my loop is running? What is the value of x for us? What is the value of x for us? Tell me.
Log n.
Again, it's log n, right?
Yeah,
I can
because
just say
n is equal to 2x.
Yeah, you can take reciprocal. It's gonna be 2 to the power x divided by n equal to 1. So I shift 2 to the power x equals to n. Again, take log both sides. It's gonna be log 2n for us. X comes into the multiplication format. Log 2 base 2 will be equal to 1. So x into 1 will be equal to log 2n. So again, value of x is log 2n. Again, that's a log n kind of scenario what we have got. So whether you divide repeatedly by 2 or whether you multiply repeatedly by 2, right? You're gonna end up in exactly log n operations. Got my point?
Okay. Only in this case, right? Multiply or divide by 2. Yes.
Yeah.
Okay.
Okay. What about if I say that? What about if I say you are constantly repeatedly dividing by 3, not 2? Then what should happen?
Then same it will be, I think.
I think now the powers will be changed, right? First you divided by 3 to the power 0, then 3 divided by 1, then 3 squared, then 3 cubed. This is gonna happen.
Right.
But loop run x times, right?
Then what will happen? N divided by 3 to the power x will be equal to
X.
1 at the end, right?
Right.
Then what will happen? The worst
Log
that will be
3.
this. So
Log
I can
3.
say, yeah, exactly. Right now I can say I have to say 3 to the power x equal to n at the end. So I have to apply now log 3 on both sides. Now the base will be changing. So x will be roughly equal to log 3n for us. So your complexity's base will be changing, roughly still it's log n.
Okay. Just wanted to ask this thing, Mustafa, like this log n and the other complexities
Yeah.
which we are getting, right? Like how we understand like how much time does it take for the log case?
Log case, it means that suppose that your value of n is very large, 10 to the power 18, let's say. Then here, how many times exactly to cover the entire range? How many times my loop has run, by the way? How many times the loop has run, by the way? So among the range of 10 to the power 18 elements, my loop has run exactly how many times? Log n times, let's say, log 2n times, log 2 10 to the power 18 times. Because these amount of powers of 2 are residing there, right? So what is this value equal to? You bring your 18 to the multiplication format, and then you say it's log 2 10. This is roughly equal to 3.5, this term. So 18 into 3.5, roughly it's gonna be approx 60 maybe. This is your overall number of times my loop will be running. So to cover a huge range, my log has just done 60 operations to solve my entire problem. 10 to the power 18 is not a joke, I guess, right? Now, few questions else we can have. Suppose that your size of the array, right? You are printing an entire array of size 10 to the power 3. Not printing, you are printing all the sub-arrays. All the sub-arrays of an array you are printing, and the array is of size 10 to the power 3. Then how many sub-arrays did we calculate for any array yesterday? For any array, how many sub-arrays exist? What we have seen yesterday? N into n plus 1 by 2, am I correct? So these amount of time my loop should be running to print all the sub-arrays, am I correct? So it's roughly, again, I can say this is roughly n square. N square number of times my subarrays needs to be generated, right? So yeah, for all the, if the size of the array is 10 cube and I'm generating all the subarrays, number of operations I would require, number of times I would need to run my loop is 10 to the power 6 approx. This is again lesser than equal to 10 to the power 8, which is the allowed limit. So if your size of the array is 10 to the power 3, right, you can generate all the subarray in the given time limit of 1 second, because 1 second allows 10 to the power 8 operation. Correct? But my point is, what if the array size has gone beyond 10 to the power 4? It is 10 to the power 5 for us. Can we generate all the subarrays for this particular array? Tell me that. Can we generate all the subarrays? So generation of subarrays is fixed. It is going to be n square for us. Value of n is large for us, 10 to the power 5. The array size is large, 10 to the power 5. So for generating all the
10
subarrays,
is to 10.
I require 10 to the power 10 operate. 10 to the power 10 times roughly. My operation should be this, which is much larger than 10 to the power 8. So this is not an allowed thing. You are gonna get a TLE verdict, and you can still get a surprise that why I am doing everything correct, but why my program is failing, because overall the number of operation has exceeded the maximum allowed limit.
So what is this TLE?
Yes,
Full
sorry.
form? TLE you
Time
said?
limit exceeded.
Okay, time limit.
Because maximum allowed limit is 1 second, that allows 10 to the power 8 operations, right? Now, if you are generating subarray of size, all the subarrays of array 10 to the power 5. So overall 10 square, n square means 10 to the power 10 operations will be required. And I think it's gonna take you 100 seconds in total, right? To print all the subarrays of this array. 100 seconds in total. So this is actually quite a bit huge thing. 2 minutes approx I'm taking just to print subarrays. So definitely for such problems, printing subarrays won't be a solution, but I have to optimize to do something. Checking for all subarrays will not be a solution for me in such cases. Maybe some kind of advanced algorithm or some kind of optimization will be required to solve such questions. So the more we solve problems, the more we are gonna get how optimization works. So before going to that, the complexity concept should be clear to you. So that's why I discussed that, the basics today.